Hi, I'm Nachiket.
And I'm Preeti.
We are computer science graduate students at NC State. In this screencast, we'll show you the working of two static analysis tools, PMD and FindBugs.
Let us first start with PMD. PMD is an open source static analysis tool. It can be run as a plugin to Eclipse as well as a command line utility. It is usable on both Windows and Linux machines. For this screencast, we shall be demonstrating on a Windows machine. The guidelines to install these tools are available at the project installation guide page. We will first show the working of PMD as an Eclipse plugin. So we'll open the Eclipse workspace. Once PMD has been installed as a plugin, we can view this under Windows, Preferences, PMD. PMD has its own perspective similar to the Java and the debug perspective, where each perspective has a set of views associated with it. To view PMD perspective, we open Windows, Open Perspective, Others, and PMD. So as you can see, this is the PMD perspective. Let us first see how to run PMD on a project. PMD can be run either on an entire project or an individual package within the project or an individual file within the project. So we'll run PMD on an entire project. So we select the project, we right click on it, select PMD and then select check code. Once PMD has completed its analysis, it will open in the PMD perspective. The PMD perspective consists of the violation overview pane and the violation outline pane. The violation overview pane consists of the violating classes and the packages in which the violations have been found. A violation is when a code has been detected that PMD finds buggy or it finds that it can make the code better. The violation overview pane also shows statistics relating the violations such as the number of violations, the violations per kilolines of code, etc. On the top right corner, we have a calculate statistics button. We also have some other color-coded buttons next to it which denote the priority for each violation. For example, red color denotes blocker violations, cyan denotes critical, green denotes urgent, pink denotes important, whereas blue denotes warning violations. So a programmer can select any of these violations based on its project's requirement. For example, suppose a programmer wants that only blocker violations should be detected by PMD. So he will select the red color, that will be blocker violations, and unselect the other type of violations. So in this case, PMD will detect only blocker violations for the selected project. Now from this package, we can select an individual file and the details of the violations in the file can be seen in the violation outline pane. The violation outline pane shows the priority for the violation, the line on which the violation was found, the rate when it was created, the rule which was used to find the violation, and an error message which gives the details relating the violation. Once we click on this, PMD will take us in the line on the source code where this violation is detected. So based on this information, the user, that is the developer, can review his code, determine whether the violation and the suggestions made by PMD are true, especially in the context of his code, and decide whether he wants to change the code. This cycle of running PMD, reviewing violations and making changes if required goes on till the developer is happy with the code and feels he does not need to fix any more violations or there are no more violations detected by PMD. So once the programmer is done, he can clear the violations by selecting the project, right clicking on it, PMD, and clear violations. This working was according to the default settings of PMD. PMD is highly configurable tool and a user can configure it as suited to his project. Let us take a look at the different configurations for PMD. To change the PMD configuration, we select Windows, Preferences, and PMD. Here we can see the PMD plugin options. Here you can set the maximum reported violations per file per rule. This should be set adequately high so that you will see all the violations, but not so high that the sheer number of violations shown becomes overwhelming. We can next see the priority level. Each priority level has a symbol, color, a value and a name associated with it. A user can change the symbol, the color as well as the name of this priority level based on his preferences. Next we have the logging options. Here PMD lets you log all the details about the violations generated. Here we can specify the path at which to generate the log files. We can also set the level of log violations in the log files. For example, we can change the log level from warning to error, or we can change it to fatal depending upon what you want PMD to log. Next we have the CPD preferences. PMD comes along with a unique copy-paste detector that checks for lines of code that are repeated in the project. Such lines are typically redundant and indicate that they could be put into a method, or maybe we could eliminate some of the code. We can configure the minimum number of lines that represent a repeating code block. The next configuration is the file filter. File filter option lets you specify the type of files over which you want PMD to skip checking for violations. Next we have the reports. PMD can generate reports in different formats. It can have like CSV format or an HTML format or a text format. So based on the user's preference, a user can select any type of reports and the reports generated will be at the location which we specified earlier. Next and the most important configuration is the rule configuration. In the rule configuration menu, we see details of each rule. Each rule has a rule name associated with it, a priority, a rule set to which the rule belongs, a type, and a language. When we click on each rule, we can see on the summary tab the name of the rule, the description of the rule, and a small example specifying what causes a violation. In the rule tab, we can see the priority of the rule. This priority can be changed. For example, suppose a user feels that this rule should belong to a critical priority for his project, he can change the priority. Similarly, he can also change the rule set to which a rule belongs. Some rules also have properties attribute. So for example, the assigned in operand, in this there are properties such as allow assignment within the conditional expression of an if statement. So we can either select it or unselect it based on our priority. Next is the exclusion tab. In this you can configure the rule so that it skips the matching code. You can do this so as to reduce the number of violations you see and you are sure that the configured code is correct and you do not want to fix it. The rules can also be grouped by rule sets. That is, you can see the different rule sets to which the rules belong, like the coupling rule set, we have design, empty code, etc. Then by PMD versions, that is the rules which are introduced in different versions. You can group them by priority, that is rules belonging to different priorities like blocker, etc. will come under one group. Then we will have type. We can group by type, we can group by language, we can also group by regex filter. The rules can also be imported, the rule sets can also be imported.
Now moving on, let us see the working of PMD from the command line. For running PMD from the command line, we need to download and install the PMD command line tool. Once we have downloaded it, we need to go to the PMD folder where bin is located. From there you can type PMD --help. This will show you the options with which you can run PMD. Of this, mandatory are a Java source code file name or directory, a report format, and a rule set file name or a comma delimited string of rule set file names. Now what we are doing here is that we are giving the source path of the source Java files We'll set the format as HTML and we'll use the Java basic rule set. The output of this, we are writing it into a report.html file. Now PMD is running in the background and writing down all the violations into the remote report.html file. When we go to that file, we can see the report in HTML format where we can see the number of the violation, the file in which the violation was generated, the line number at it, and when we click at the problem, it will redirect us to the PMD website where there is a description regarding the violation. Now let's take a look at FindBugs. FindBugs is another static analysis tool which works on compiled Java classes to find bugs in your code. FindBugs can be run as a plugin to Eclipse, NetBeans, Maven, etc. It can also be used as a standalone Java application. Similar to PMD, FindBugs also has its own perspective which can be seen from Windows, Open Perspective, FindBugs. To run FindBugs, we can run it on the entire project, a single package, or a file within the package. To run FindBugs, we can do right click, FindBugs, FindBugs. Now FindBugs will scan through all the source files provided to it. As we can see, it shows the number of bugs next to the file in which those bugs were found. When we go to the FindBugs perspective, we can see three views: the Bug Explorer view, the Bug Info view, and the Bug Reviews view. The Bug Explorer view organizes the bugs in several categories or groupings. We can change how we view these groupings by either we can select the bugs grouped by project, category, detector plugin, package, class, confidence, bug rank, pattern type, or pattern. Here we can see the bugs organized according to category. There are 4 bugs of type correctness and 2 of type dodgy code. When we click on one of the bugs, it will take us to the line in the code where the bug was found. The color of the bug denotes the severity of the bug. Related to the bug, we can see information in the bug info view where we can see a description related to the bug, the confidence level, that is with what confidence FindBugs thinks that this is a bug warning, the rank of the bug, that is how severe it is, the pattern which found this bug, and category of the bug. We can change the FindBugs properties by clicking on FindBug, right click, properties. Here we can see different FindBugs configurations. We have the reporter configuration. We can set the minimum rank to report. 1 is most severe and 20 is least severe. As we increase the minimum rank, we get to see more violations or more bugs. The minimum confidence to report. Confidence related to FindBugs is with how much confidence FindBugs can claim that this is a bug. Here are the different categories of bugs that FindBugs will report. We can select one or many of them. We can also select what should happen when a particular type of bug is found. Should we get a warning, or should we get an error, or should it be an info? In the filter files tab, we can select the files that FindBugs should skip checking. In the detector configuration, we can get information related to the different detectors that FindBugs has. Each of the FindBug detector runs over the source code and checks for bug warnings. For each detector, there is a detector ID, a pattern, the speed at which the detector runs, and the category to which it belongs.
FindBugs can also be used as a standalone Java application. So now let us see how to use it. Once we open the FindBugs UI, we can create a new project by File, New Project. Here we can give our project some meaningful name. Let's say Testing FindBugs. Then you can click on the Add button to choose Java archives such as zip, var, er, or directory containing Java classes to analyze for bugs. And we can select multiple archives or directories. So now here we are selecting the bin folder which contains our compiled Java classes for our project Java libpst. And here we can add the source code directory of the Java archives to be analyzed for bugs. So we are choosing the source folder. One important point which you need to remember here is that the source code directory must be the root of the Java package hierarchy. We can also select additional archives or directories in the auxiliary class path location. These are used as the archives of the directories we are analyzing for bug, references additional classes which are not included in the archives of the directories being analyzed and not present in the Java runtime class path. Once we have added the classes which we want to analyze, then we can click on the analyze button. So at this time, at the background, FindBugs is scanning through our files to find for potential bugs within them. So once FindBugs has completed its analysis, we can see on the upper left pane the bugs which are detected by FindBugs. You can also see that this is a hierarchical representation. So once we click on one particular bug, on the right side, you can see the source code and the line on which the bug was found. At the bottom, you can see the details relating to the bug. So the developer can read these details which are at the bottom and he can decide whether he wants to fix the bug or ignore the bug. The detail pane will also tell you the type of pattern which was used to find this bug. Another important feature here is that the programmer or the reviewer, he can also write comments for this particular bug, and for this he needs to enable the cloud plugin. These review comments, they can be either from a particular category, like he can write maybe must fix this bug, bad analysis, etc., or he can write his customized comments here. And once this project is saved, along with this the review comments will also be saved. So when the programmer opens it again, he can go through these review comments for each bug, and based on that he can decide whether he wants to fix or ignore the bug. Also, you can view these bugs from within a date range. You can also group bugs by different category or the bug rank, bug kind, etc.
Now that we have seen the working of both these tools, we want to discuss our experience using these tools. From our experience, rule set and detector configurations are most important. The violations we view and fix are dependent on the rule sets we configure. If we configure the rule sets that are not relevant, we will not find any useful warnings. In fact, we also observed that the violations that get fixed over successive versions of a project tend to belong to the same rule set. In corollary, the violations that do not get fixed tend to belong to the same rule set. By mining the information of which violations were generated and which were fixed over successive versions of a project, a precise rule set configuration can be built. This will reduce the number of violations that the developer has to review, reduce the time needed to review, and reduce the chance of missing out an important violation. By building more specific rule sets, the developer can focus on removing specific types of problems, improving important aspects of the code. In fact, the rule sets can be exported and used for similar projects. The option to build your own rule set or detector is also very convenient, since there might be certain checks you want to do on your project. For example, all errors must be logged to a file, none of the card numbers must be stored on a database or a file, etc. The best way to use rule sets is first configure and run a small set of basic and most important rule sets. Then, as code gets refined, run PMD using more rule sets. Now let us discuss the ease of use and learning for both these tools. For FindBugs, one of the positives is the Bug Explorer view. We found that the categorization in the Bug Explorer view is very good. The option that we can view the bugs categorized according to bug pattern, package, class, etc. is very handy in reviewing the code quickly. PMD lacks this option of viewing the violations grouped by rule set. The confidence measure of FindBugs is also very useful. Each detector comes with a confidence measure that denotes how confidently FindBugs can say that this line of code contains a bug. FindBugs also displays the number of bugs detected next to the package or the class. This helps us focus our reviewing effort to a set of most important classes or packages. Negatives related with FindBugs is that it takes a long time to run. But maybe this is a given since it works on the compiled bytecode. For PMD, the positives is that we both found that it is very easy to learn and use. It has better visualization of violations. It gives colors and symbols to all the rule sets, and these are configurable. It also shows an aggregation of the colors and symbols, which tells us that which package has the most severe problems. PMD also comes with very good reporting and logging options where we can generate reports in different formats. The negatives with PMD is that it lacks a very good violations explorer view like that of FindBugs. And another problem with PMD is that it has too many rule set configurations, which end up having the developer to go through a large number of violations which aren't even relevant to his project and turn out to be false positives. Now let us discuss our recommendations on how to use these tools. The default rule set for PMD are basic Java, import statements, and unused code rule sets. What we suggest is to iteratively run PMD over different runs with the project with different rule set settings. In the first run, we can use basic Java, import statements, and unused code, which is the default setting. And optionally, we can have our own custom rule set for that project. In the second run, we can run the design rule set, empty code rule set, optimization rule set, strict exception rule set. Optionally, if we are using a lot of strings and string buffers, or if we are migrating older code, we can use the string and string buffer rule set and the migration rule set. In the third run, if we are doing any kind of logging, we can use the Java logging rule set, especially to get rid of system print statements that we generally put for debugging. We can also use the unnecessary rule set to remove any unnecessary part of code. In the fourth run, we can use the controversial rule set, which has a set of rules which are not completely agreed upon by the developer community. Then we can run the coupling rule set, the naming rule set, but only if we want to strictly adhere to some naming convention, and the code size rule set. We can run PMD iteratively with different priority levels set on and fix the most severe priority first. And another recommendation is to use PMD reporting, since this can help in data mining. Our recommendations with FindBugs is that FindBugs default settings are good enough, and by default FindBugs has detectors of type dodgy code, bad practice, correctness, performance, multi-thread correctness already configured. We would suggest using FindBugs prior to PMD, since it finds only a small set of bugs first, and once those are fixed, we can then turn to PMD. Being able to put reviews to bug warnings and option of uploading to cloud is very handy in FindBugs. These are references related to the screencast. Thank you.